So today, this is a very necessary topic for me to cover in a video. I've been getting a lot of requests for it, and to be quite honest, shame on me for not getting this out sooner, but factoring polynomials. We're going to go all the way up from basic factoring to right before you get into the quadratic equations, and then my next video is going to be about the quadratic equations. So here we go. First, we're just going to talk a little bit about factoring in general, because everybody needs to refresh on this. I see so many college students, and so don't be ashamed, because these are college students, high school graduates, college students, and they're completely lost on factoring because you tend to forget, because you go over factoring when you're like in second, third grade, and then it's never mentioned again, and then everybody just expects you to know how to do it. And so you get into college and you go into your college math classes and you're like, what are you talking about? So first we're going to do factoring. Let's talk about factors of 12. And 12 is just a random number that I picked, okay? So they need to know the factors of 12. First, the term factors to begin with just means the divisors of a number. So you might say, what? What does that mean? Okay, so in more simple terms, factors means the whole numbers, and whole numbers, we're not talking about decimals or fractions or anything, but when it comes out even, the whole numbers that you can multiply together to get your target number. So your target number in this case would be the 12. So if they say the factors of 12, they're asking you for the numbers that can multiply together to get 12. And for you movie fans like me, you'd think of the 12 as the main character for the movie. So that's your target number. So you want to get the numbers that when they multiply together, the answer is 12. And again, 12 is just a random number that I picked. It's factoring anything, any number. So for example, 12, if you want factors of 12, we're first going to start with 1. Okay, so 1 times what equals 12? Well, of course, 1 times 12 equals 12, because 1 times any number equals that number. Now we're going to go up to 2. See, you just go 1 and then you go 2. So 2 times what equals 12? Well, 2 times 6 equals 12. Now we're going to go up to 3. 3 times what equals 12? Well, 3 times 4 equals 12. Now we're going to go up to 4. We went from 1 to 2 to 3. Now we're going to go to 4. 4 times what equals 12? Well, 4 times 3 equals 12, because we just did that, this previous thing. It was just backwards. 3 times 4 equals 12. 4 times 3 equals 12. So again, the factors are the numbers that will multiply together to get the target number. And in this case, the target number is 12, but it could be anything. And now it's important to remember that we're only talking about numbers that divide into your target number evenly. Now we lucked out here with the number 12 because 1 goes into 12 12 times, 2 goes into 12 6 times, 3 goes into 12 4 times, but not all numbers are like that. So if you get to a number like, let's say, the number 5. Does 5 go into 12 evenly? No, because 5 would have a remainder. If you go 5 into 12, well, 5 into 12, well, 5 into 12, the closest you can get is 5 into 10, and that's 2, so 10, and then 2 minus 0 is 2, so 20, and then 5 into 20 is 4, so 2.4. See, that's not what we're going for. So 5 does not go into 12 evenly. We only want the numbers, we only want the easy answers. We only want the numbers that go into 12 evenly, or we only want the numbers that go into the target number evenly. And now, as you can see, we did 1 into 12 is 12, 2 times 6 is 12, 3 times 4 is 12, and now 4 times 3 is 12. So once you start repeating yourself, see, because we did 3 times 4 is 12, but now we have 4 times 3 is 12. This is the exact same thing, it's just backwards. So once you start repeating yourself, you're done. You can stop. So now, I don't know if you noticed this or not, or if you know that you're doing this, but remember when we have to reduce those fractions, when you had to reduce those fractions to a simpler fraction, like here's 1/7 over 56, we have to make them smaller, and now you're not changing the value. The value of the fraction is exactly the same, but the numbers are going to be smaller, and it's going to demonstrate the exact same fraction, but with smaller numbers. So we need to reduce this to simplest form. Well, factoring is what you did in order to get that. So let's do 7 first, because 7 is kind of a tricky one. Because guess what? 7 is a prime number. And a prime number means that nothing goes into it, except for 1. So we have 1 times 7 equals 7, and that's it. And you're done, and that's it. Because it is a prime number. That's what a prime number means. There's no other number that actually divides into 7 evenly. Okay, so nothing to do on 7, so let's go on to 56. So let's see, we got 56. So let's break 56 apart into numbers that when you multiply them together, you end up getting 56. So you start with 1. So 1 times 56 is 56. Now does 2 go into 56? Yes, because 56 is an even number, so you know 2 is going to go into it. So 2 into 56, or 56 divided by 2, is 28. So 2 times 28 is 56. Now what about 3? Does 3 go into 56? No. 3 does not go into 50. Well, 3 goes into 56 if you want a decimal. But when we're factoring, we don't want decimals. When you're factoring, you're only looking for the numbers that multiply together. They get the even result, the even number of 56. And 3 does not go into 56. So let's go on to 4. What about 4? Does 4 go into 56? Yes, 4 goes into 56 14 times. So what about 5? Does 5 go into 56? No, of course not. Because any number, anytime you take something times 5, it's going to end up in either a 0 or a 5 at the end of the number. And 56 does not have a 0 or 5 at the end of the number. So no 5. So what about 6? Does 6 go into 56? No. No, it does not. 6 does not go into 56 evenly. So what about 7? Does 7 go into 56? Aha! 7 goes into 56. And you might need to use your times tables for this if you don't have your times tables memorized. But 7 goes into 56 because guess what? 7 times 8 equals 56. So 7 goes into 56. Now what about 8? Does 8 go into 56? Of course, because we just did this right here. 7 times 8 is 56. So of course 8 times 7 is going to be 56. And then you can stop right there. Because once you start repeating yourself, once you start repeating the factors, you're done. So we identified that 7 times 8 equals 56. Okay, now let's go back to the original problem. What the heck were we doing again? I forgot because we are over here doing factoring and now I don't even remember the problem. Oh, okay, so it's 7 over 56 and we need to reduce that. Well, we did the factoring for 7, and since 7 is a prime number, the only things that can go into 7 are 1 and 7, and that's it. But 7, fortunately, 7 also goes into 56. It goes into 56 8 times. So if you want to reduce 7 over 56, we know that 7 is going to be our factor number that matches both of these. 7 can go into 7, and 7 can go into 56. So how many times can 7 go into 7? Just 1. And how many times can 7 go into 56? Well, remember back here, our factoring chart? That's 8. So that's your answer. If you reduce 7 over 56, you're going to get 1/8. And now this does not change the value of the number you're talking about. We're just using smaller numbers in a fraction to represent the exact same fraction. Now, if you get confused about fractions, if you go to my video on how to take notes in math class, the entire thing, it's about exactly doing this kind of stuff because it is very relevant to this factoring right here. It's not a coincidence that factoring and fractions sound kind of similar. So if you're confused about fractions, go to that video about how to take notes in math class. Not only will it teach you a better way to take notes in math class, but it's going to show you about fractions. You can just jack up the playback speed, to 1.5 or 1.75. Make me sound like a chipmunk just so you can rattle through it just really quickly and get a brief refresher before you go on with the rest of this video. So let's look at some viral math. This was on Facebook, and I reposted it and just laughed and laughed and laughed at everybody arguing over it. So we have 8 divided by 2 times, parentheses, 2 plus 2. Now, just take 1 second, pause the video, and see if you can get this. Okay, you back? Okay, everybody argued over this, but there's only one correct answer to it. Why? Because of PEDMAS. PEDMAS, I know you've heard of this before, maybe not in these terms, but PEDMAS stands for parentheses first, and then your exponents, and then division, and then multiplication, then addition, then subtraction. In that order. It must be in that order. And also, in addition to PEDMAS, you have to do everything in that order, but you also, if you are faced with a decision on, well, both are kind of equal in PEDMAS, which one do I do first? You always go left to right. Just like we read in the Western European countries and the Western countries, we read left to right. Not everybody reads like that in the world, but in the European and Western countries, we read left to right, and that's how you do math. Left to right. So you ready for the right answer? The answer is 16. Not 1, 16. Why? Because of PEDMAS. So now that we know you do anything inside the parentheses first, then any exponents, then any division and multiplication, then any addition and subtraction. Now let's solve it again using PEDMAS. Well, it says we have to do parentheses first, so that means we have to take this 2 plus 2 first. So 2 plus 2 is 4. So now we have that 4 in parentheses. I'm going to bring this down here. Okay, so now we have this 2 outside of the parentheses, and then we have this division sign, and then we have this 8. So now, after we solve the parentheses, we have 8 divided by 2 times 4. Well, now we have to look at PEDMAS, and when we did the parentheses, now what about exponents? Are there any exponents here? No, there's no exponents, so we can move on. What about division? Is there any division here? And division and multiplication can kind of be done at the same time. These are like kind of, they tie, and so does addition and subtraction ties. But division, can any division be done? And any multiplication be done? Yes, because this is division, and 2 times right outside of a parentheses, that's multiplication. But we go left to right. So we got to do the 8 divided by 2 first. So 8 divided by 2 is 4. And then 4 times 4 is 16. Because of PEDMAS. Alright, so now we're getting into more complicated problems right here. We have a 3 plus 5 in parentheses. Remember PEDMAS. I'm going to write this down at the bottom. PEDMAS. You got to do these in order. So you got to do the parentheses in order. Parentheses first. So we have 3 plus 5, close parentheses, open parentheses. And what does this mean when there's nothing in between a number or a set of parentheses? That means multiply. So 3 plus 5 multiplied by 4 plus 6. Now you can't go off willy-nilly and start multiplying the 5 and the 4 and the 6 and the 3 because PEDMAS, you got to do the parentheses first. So 3 plus 5 equals 8. And then 4 plus 6 equals 10. So 8 times 10 equals 80. And that would have been totally different if you would have done it in a different order. Now let's go over here and do this one. We have 5 outside the parentheses, and if there's nothing between the 5 and the parentheses, that means multiply. Just an invisible multiply sign. But we have 2 plus 10 inside the parentheses, so we got to do that first because of PEDMAS, parentheses first. So parentheses first, we got to do 2 plus 10, and that's 12. And then we bring this 5 down. So 5 times 12 is 60. Now see, if you would have done that out of order, 5 times 2 plus 10. If you would have gone 5 times 2 is 10, plus 10 is 20. See, that's a totally different answer than when we did it correctly up here, we got 60. So you have to be on the lookout for doing things in the appropriate order, and there's a way to work around that, and I'll show you that in a sec. So now, as I said, there's a way around doing the inside the parentheses first, which there's a reason for that, and you'll see why we have to figure out ways around doing this, doing what's inside the parentheses first, when we start using variables, when we start using like x's and y's, because you can't add an x to a 3. You still just have x plus 3. So we have this 5 on the outside next to a parentheses, and then inside the parentheses is 2 plus 10 and close parentheses. And so what does it mean when there's just a number right butted up against parentheses with nothing else there? That means multiply. So it's 5 times the parentheses of 2 plus 10. So we could do what's inside the parentheses like normal. 2 plus 10 equals 12, and then 5 times 12 equals 60. But we can take the 5 and distribute that back to both sets of numbers inside the parentheses. And this is important because we can't just take the 5 and go 5 times 2, which is 10. So we'll just bring this down here as 10, and then just bring down the plus 10. Okay, that's the wrong way to go. That's not how we're going to do this. Because the 5, this 2 and this 10 are separated by an addition sign. So an addition or a subtraction sign is the same thing for this rule. This 2 and 10 is separated by an addition or a subtraction sign. So that means the 5 has to be multiplied, since it's outside, coming from outside the parentheses, the 5 has to be multiplied to both sets of numbers. So that means 5 times 2 is 10 plus, and then 5 times 10 is 50. And then we can add the 10 and the 50 together and get 60, which was the number we had on our previous page back here. The 5 times 2 plus 10, we did the 12, and then the 5 times 12 is 60. So it comes out the same if and only if we distribute that 5 to both sets of numbers on either side or both sides of the addition or subtraction signs. So let's try it down here. Let's try another one. We have this 8 outside of the parentheses, and then we have 4 plus 6 inside the parentheses. And if you need a good way to remember this, I just think of it as like if you come over to somebody else's house, you're going to walk around to all the family members and say, "Hi, how are you doing?" and introduce yourself. The 8 has to come into the house and come over and say hi to the mama 4, and then it also has to go over and say hi to the grandma 6, because 8 has manners. So when 8 comes over to somebody else's house, they go around and they say hi to everybody, all the family that invited them in. So if that helps you remember it, then by all means, please use that analogy. So we have this 8 times 4, which is 32, and then we bring the plus sign down, and then 8 times 6 is 48. So now we have 32 plus 48, which is 80. So if the number can go into the parentheses and distribute itself on both sides of the addition or subtraction sign, then it can also come out again. You can bring it out. You can do the reverse step and do the opposite of that. So let's look at this first problem, and we just have parentheses 21 plus 49. Now here is where we get back to factoring. And remember, factors are the numbers that when multiplied times each other, they end up getting the target number. So in this case, our target numbers are 21 and 49. So let's do 21 first. We know 1 times 21 equals 21. So does 2 go into 21? Nope, because 21 ends in an odd number, so 2 doesn't go into odd numbers. What about 3? Does 3 go into 21? Yes, 3 goes into 21 7 times. Now, does 4 go into 21? Nope. 5 go into 21? Nope. Does 6 go into 21? Nope. Does 7 go into 21? Yes, it goes into 21 3 times, because we just did that right here. So since we started repeating ourselves, we're done. Now let's do 49 real quick. So 49, we know 1 times 49 equals 49. Does 2 go into 49? Nope, because it's an odd number. Does 3 go into 49? Nope. Does 4 go into 49? Nope. 5? Nope. 6? Nope. 7? Does 7 go into 49? Yes, it does, because 7 times 7 equals 49. So the multiples, or the factor number that both 21 and 49 have in common, is 7. And you always want to get the biggest one. And you always want to get the biggest number that you can possibly manage, that these your target numbers share. So they both have 7 in common. So that means 7 is going to be your factor number. So we're going to pull 7 up out of this parentheses. So let's do it with 21 first. we're going to write the 7 outside of here. And 7 times what equals 21? Well, if we look down here in our factor table, we've figured out that 7 times 3 equals 21. So that turns this 21 into just 3. Because 7 times 3 equals 21. So if we were to put the 7 back in there, like we just did with the 5 in the previous problem, then we would end up getting 21. So now the 21 is a 3, and we have 7 outside of the parentheses. But we're not done. We also have to do this with 49. And what did we say 7 times what equals 49? Well, 7. 7 times 7 equals 49. So this 49 is going to be reduced to 7. So see, it's just like reducing fractions almost. You're just pulling the same number out of both of them. And so this is still going to be the same value. It's just being shown with smaller numbers. So the answer for this is, and keep that 7. You got to keep the 7. Otherwise, you change the value. That's 7 outside the parentheses now, and inside the parentheses, we're left with 3 plus 7. And let's see if we work it out normally what we're going to get. 3 plus 7 is 10, times 7 is 70. Now, if we were to just have done the original problem, 21 plus 49, and that's it, well, 21 plus 49 is 70. So we got the same answer. So see how that works, how we can do that either way and still get the right answer? So let's do the one down here, 24 and 72. So let's factor 24 first. We got 1 times 24, 2 times 12, 3 times 8, 4 times 6, and 6 times 4. So we're done because we're repeating ourselves. These are the same. They're just backwards from each other. All right, and so now let's factor out 72 because we don't know what number we're going to use for the 24 yet until we see what numbers we got to work with 72. So we got 1 times 72, 2 times 36, 3 times 24, 4 times 18, and 6 times 12, and 8 times 9, and 9 times 8. So we're done because we're repeating ourselves now. 8 times 9 and 9 times 8, same thing. So now 72 has all these numbers for factors. So we want to pick the biggest number that both 24 and 72 share in their factor numbers. And it looks like the biggest number we have is 24. Thought it was going to be like 8 or something, didn't you? 24 is the biggest number that 24 and 72 share. So we're going to pull 24 out of this. So let's do 72 first. We're going to pull out 24 out of 72. Now, 24 times what equals 72? Well, let's look back at our factor tree that we did. Here's the 24, and it's saying 24 times 3 is 72. So that's going to turn this 72 into 3. So far we have 24 outside the parentheses, and we have plus 3 at the end of the parentheses. Okay, so now we're going to take 24 out of 24. Now, here's the thing you got to remember. When you're taking 24 out of 24, let's look at this factor tree over here. What times 24 equals 24? Well, that's 1, isn't it? 1 times 24 equals 24. So this 24 doesn't just go away because we took it out and put it outside the parentheses. This 24 turns into a 1. So that's 1 plus 3 inside the parentheses, and outside is 24. So don't forget to bring that 1 down, because 24 times 1 is 24. It's not 24 times 0 is 24, which would just make this nothing, and we would just have 3 in the parentheses. It is 1 plus 3 in the parentheses. So if we were to work this out normally, 1 plus 3 is 4 times the 24 on the outside of the parentheses. So that's going to equal 96. And if we would have just done the original problem, 24 plus 72, that would have given us 96. So see, if we forgot to carry that 1 down, we wouldn't have gotten the right answer. Okay, so let's recap a little bit. A couple of pages ago, we were going over these problems. Let's specifically look at this one up here, 5 times parentheses 2 plus 10. And remember when we were working this, and I said that if you do things in order of PEDMAS, that there's actually a workaround from doing the insides of the parentheses first? If you don't remember, here's a clip. Is 60. Now see, if you would have done that out of order, 5 times 2 plus 10. If you would have gone 5 times 2 is 10, plus 10 is 20. See, that's a totally different answer than when we did it correctly up here, we got 60. So you have to be on the lookout for doing things in the appropriate order, and there's a way to work around that, and I'll show you that in a second. See, I told you. So we're going to go back to this problem, this 5 times parentheses 2 plus 10, and we're going to do this again just real quick, and then I'm going to go into showing you how to do the workaround for the parentheses and why you need to know that and what it has to do with factoring. Remember, if we have 5 times the parentheses 2 plus 10, we have to do what's inside the parentheses first because of PEDMAS. Parentheses, exponents, division, multiplication, addition, subtraction. So 2 plus 10 is 12. And then you bring down that 5, and 5 times 12 is 60. But, as I had just been going over, you can distribute, you can use the distributive property, now not property like a house, but property like a characteristic of something. Like I have brown hair and I laugh really loud. Those are properties or characteristics. And distributive, that's distribute. You are distributing something. So when you go to hand out a whole bunch of flyers to a whole bunch of different people, inviting them all to come and see your band, That's you're distributing flyers, so distributive. And so you're distributing the 5 among both sets of these numbers in here. Because remember, you have to have good manners when you're invited over to somebody's family's house. So you should go around to the mom and introduce yourself and thank her for having you over. And you should go to the grandma and introduce yourself and thank her for having you over. So 5 times 2 is 10. And the 5 has to go over to the 10. So 5 times 10 is 50. And since this is an addition sign in between the two numbers, we're just going to bring that down with us. So 10 plus 50 is also 60. So see, you're going to get the same value, the same answer, whether you add what's in the parentheses first and then multiply it by 5, or if you distribute the 5 throughout the parentheses and then add them together. So that is the workaround for not solving what's inside of the parentheses first. And the reason why you're going to need to know that is because we're going to start using x's and y's and such. But before we do that, we're going to do the opposite of what we just did, because if it can go in, if that 5 can get distributed within the parentheses, it can come out. So this is a different problem. This is 21 plus 49. And actually, if there's nothing outside parentheses, nobody would write it like that. You would just see 21 plus 49 with no parentheses. But we need to factor 21 and we need to factor 49 and see if we can pull out some number and set it outside of the parentheses and get some smaller numbers inside here. So let's do 21 first. And I know this is repetitive because we did this problem already. So let's go through it really fast. So we got 1 times 21, no 2, 3 times 7, no 4, no 5, no 6, and then 7 again. So 49, 1 times 49. No 2, no 3, no 4, no 5, no 6, but 7 times 7 is 49. So these both share the common number of 7, so that's going to be our factor number. That's going to be the number that we pull out of the parentheses and set it outside. So for the 21, it's 7 times 3 is 21. So that's going to turn this 21 into a 3. And for the 49, it's 7 times 7 is 49. So that's going to turn this 49 into a 7. So when we're pulling it out, we're doing the opposite of what I just showed you, the opposite of the distributive property. Our answer will be 7 times parentheses 3 plus 7. So why am I taking the time to repeat this and to refresh and recap with you before moving on? Well, because now we're going to do those scary equations that have those letters in them that scare people. So here's some equations with some x's in there, so don't be scared. It's exactly the same rules. The only thing is that x just stands for a question mark. You don't know what that number is. You just put that x there just to kind of hold its place. But I've done tutoring sessions with students who get anxiety about seeing letters in their math, and so we just did the entire assignment using a question mark instead of an x. And they were cool. And they were like, oh, okay, I get it now. So an x, it just stands for question mark. You just don't know what that number is. But since we don't know what this number is over here, and we don't know what this number is over here, let's take this first set right here. Let's take this first problem, 3 plus 6 in parentheses, and then plus, and then another set of parentheses, 4 plus 2x. Now see, you can't do, and this is why I recapped that stuff with you just a minute ago, because you can't add 4 plus 2x, because we don't know what this number is. And if you were to go like, oh, well, 4 plus 2 is 6, so that must be 6x. See, that's not going to work. It doesn't turn out right. Because let's just say, for example, let's see, we got 4 plus 2x. Let's say, for example, that x equals 3, okay? So if x equals 3, and we have 4 plus 2 times 3. Well, because of PEDMAS, we have to do the multiplication first. And 2 times 3 is 6. And then plus 4 is 10. But if we were to do it the other way, like we were going to do it up here, if we were going to go, well, 4 plus 2 is 6, so that must mean 6 times 3. Well, then 6 times 3 equals 18. So 18 and 10 are not the same number. So see, it doesn't turn out right. So the whole thing is because we don't know what this x is, and this x is tied to the 2 by multiplication, not by addition. If it would have been 4 plus 2 plus x, then we could have gone 4 plus 2 is 6, and we could have said 6 plus x. That would have been fine. But because the 2 and the x are tied together with multiplication, that's what makes it so we can't solve this 4 plus 2x until we know what the x is. So let me stop talking about it and actually do it. So let's solve this problem. First, let's take this first set of parentheses right here, because you see these two sets of parentheses are hooked up together by an addition sign. So notice that. You don't have to do anything about it, just notice it. So let's do this first set of parentheses first. So let's factor 3 first. 1 times 3 is 3. Now, is there anything else times anything that equals 3? No, of course not, because 3 is a prime number. So let's do 6. 1 times 6 is 6. And 2 times 3 is 6, and that's it. All right, so what factor numbers do the 3 and the 6 both have in common? Well, it's the 3, right? So we're going to take that 3, and we're going to set it outside of the parentheses. So now we have 3 outside the parentheses, and this 3 times 1 is 3. So that's going to turn this, when we take the 3 out and set it outside the parentheses, that's going to turn this inside 3 into a 1. Because remember, I showed you that thing. You got to remember to put that 1 there. It's not 0, it's 1. And then let's do the 6. We take 3 out of the 6 and put it outside the parentheses. It's the same 3. And, well, 2 times 3 is 6. So if we take the 3 out, that's going to turn that 6 into a 2. And then there's an addition sign in between them that we bring down. So now we have 3 times the parentheses 1 plus 2. So let's do the second set. Let's do this parentheses 4 plus 2x. Now we have to factor 4, and 1 times 4 is 4, and 2 times 2 is 4. And that's it. And then, oh, well, how do we factor 2x? And the reason why I'm not breaking them up into a 2 and an x is because since they're hooked together by multiplication, they're going to stick together like that. It's not like addition. Like if it was 2 plus x, they would have to be done separately. But since they're multiplied together, you can take them all as one unit. So 2x. 1 times 2x is 2x, right? Also, 1x times 2 is 2x. Aha! See, this gets a little bit more complex here because we got two numbers going at the same time. But so we have x times 2 is 2x, 1 times 2x is 2x, and that's about it. So now we look at what we have with factoring 2x and what we have factoring the 4 and find out the highest number that they share in common, that they have in common. And that would be 2. So we can take a 2 out of that parentheses. So we're going to have 2 parentheses. And then since we took a 2 out of this 4, that's going to turn the 4 into a 2 because 2 times 2 is 4. And then that's a plus sign in between them we're going to bring down. And then this 2x, if we take that 2 out and put it over here outside of the parentheses, we just have x left, right? So now we have 2 times the parentheses of 2 plus x. And now we just remember that these two sets of parentheses were linked up by a plus sign. So that's how we write it. We're going to go 3 parentheses 1 plus 2 plus 2 parentheses 2 plus x. And just like that, we can put an x, we can distribute an x into a set of parentheses as well. So x times 2 is 2x, and x times 10 is 10x, and we carry the addition sign down. So if we have x outside the parentheses of 2 plus 10, that would end up being 2x plus 10x. So that's going the other way. That's doing the distributive property into the parentheses. We're using x instead of an actual number. So anytime you see x, don't panic. Just remember, x stands for question mark. So let's look at these a little bit closer. So we just did this one up here, the upper left one. We did this 3 plus 6 plus 4 plus 2x. Okay, so if we were to actually do this following PEDMAS, like inside the parentheses, that would be 9. And inside these parentheses, it would still just be 4 plus 2x because there's an x there, so we can't add the 4 to it. So we can undistribute at least the 2 out of here and go 2 plus x. And all of that would be the plus and the 9 here at the beginning. So we would have 9 plus 2 parentheses 2 plus x. But do not make the mistake of going 9 plus 2, oh, well, that's 11, and then go 11, 2 plus x. Because PEDMAS, 2 is hooked up to the parentheses by multiplication. So you can't do addition before you do multiplication. So the final answer would be 9 plus 2 parentheses 2 plus x. You can't go any further than that. Now, down here underneath, we have the same thing, but look, I put some more x's in there. So look what we can do. This first one, we know that between the 3 and the 6, we can pull the 3 out of the parentheses. So 3 divided by that 3 equals 1, and then the plus sign. And the 6 divided by that 3 equals 2. But then we have this x, and we didn't take a 3 out of the x because we took the 3 out of the 6 that's hooked up to the x by multiplication. So we don't have to worry about that. So we're just going to bring down the x with the new number, the 2. So now that's 3 times parentheses 1 plus 2x. And then you bring down that addition sign. And now we have this 4x plus 2x. Ah, before we were taking the number 2 out, and then we would have 2 plus x left over. But look, 4x plus 2x, these both have x's in them. So we can also take the x out of the parentheses as well. So we can take 2x out of the parentheses. So 4x divided by 2x is just 2. See, there's no x anymore because we took that x out. We took the x completely out. And 2x divided by 2x is just 1. So when you're dealing with x, if you take that one x out, there's no more x left inside the parentheses. So let's do this again down here, and we have an x squared, and we have an x cubed, and we have a regular x. And so you'll start to get the hang of this maybe once you see this stuff. So we know that we can take a 3 out of here, and that turns into 1, and that turns into 2. But this 6 didn't have any x with it. And so we can't take an x out of the parentheses. So we have to leave that x squared alone. Leave it how it is. So this part of the answer is 3 parentheses x squared plus 2. And then we bring down the addition sign. And now here's this other part of the other parentheses, 4x plus 2x cubed. So that's x to the third power. So x to the third power means x times x times x. So you take this, whatever this number is, and that's how many times you write the x down. And then you just multiply them all together. So that's what that cubed is. So, and then this 4x, we only have the x one time. So we can take, not only can we take a 2 out of the parentheses, but we can take one of the x's out. So 4x divided by 2x gives us just 2. But when we take 2x out of 2x cubed, we're only taking one of the x's out. So that turns into a square. We just go 3 minus 1, because we only took one of the x's out. So just like over here, the x cubed, x to the third power, is 1, 2, 3 x's all multiplied together. So if we took one of the x's out, that still gives us 1, 2 x's left. So that's x squared. So this final number at the end of this parentheses, the 2x cubed divided by 2x, we took 2x out, is going to end up being x squared. So the answer is 3 times the parentheses of x squared plus 2 plus 2x times the parentheses of 2 plus x squared. Now, if we take stuff out, we can put them back in. So going back up here to the right column, we have x distributed, we did this on the other page, is 2x plus 10x. And then we can actually add those together. 2x plus 10x is 12x. But here we have 2x plus 10x, and we want to take something out now. We want to factor it. We want to go the other way, like we were doing over here. Now we want to do this to this problem. So we can factor 2. 2 times 1 is 2, and that's it. 10 times 1 is 10. 5 times 2 is 10. And so look, we have common shared number right there, and that's what we can take out. But also, they each have an x, so we can take the x out as well. So we can take 2x out of the parentheses, and what will be left over is just 1, because the x is gone, we took that out, and the 2 is gone. So there's just one left over, plus 10x divided by 2x is just plain old 5. So 2x plus 10x is the same as 2x times parentheses 1 plus 5. Now let's do another one over here. What if we got 2x squared plus 10x? Well, we know we can take the 2 out. Right, we can take the 2 out of both the 2 and the 10. And we can take one of the x's out. So we can take one of these x's out. So we can go from 2 to 1. And we can take this one out. So we have 2x outside the parentheses again. So the 2x squared that we originally had divided by the 2x that we took out leaves us 1x left. We got rid of that 2 and we got rid of one of the x's. So we just have the 1x left inside the parentheses. And then the 10x, when you take 2x out, is going to be just plain old 5. So this answer is going to be 2x times the parentheses of x plus 5. Now let's look at some more problems, and I'm just going to direct your attention to these problems over here in the bottom right. So this one right here, we're going to distribute this x into the parentheses. And I want you to see how to do this because it's a little bit different. When we go x and we distribute that to the 2x, well, we're still going to have 2, but this is going to be x times x, isn't it? And what is x times x? That's x squared. So inside the parentheses is going to be 2x squared when we distribute that x into there. And the same goes for the 10. When we take that x and distribute it over to the 10x, that's going to end up being 10x squared. Now let's look down here at the bottom. This x into 2x plus 10y. So x times 2x is going to be 2x squared, because see, x times x. But we go over here to the 10y, and there's no x for the x to be multiplying itself by, so there's no x squared. It's just plain old x. But now we have a new joiner, the y, but there's nothing, I mean, you're just multiplying the x times the y, which is x times y is xy. Because y is another term for a question mark. It just means it's a different number than the x. So they had to use a different letter just to show that it's two different numbers that they don't know what they are. So if you take this x and distribute it over here to the 10y, you're going to end up getting 10xy. Okay, so now here we're going to go into, this is the exact same thing as what we've been doing, but sometimes teachers and textbooks, they want to really make sure you understand the concept, so they take all the numbers out of it, and they use these like capital A's and capital B's, and then the lowercase x's and y's, and ask you to factor these out, just to make sure that you understand the entire concept of it, and you can apply this to everything. So this first one on the top left, we have abx squared plus bx. So the capital letters they all stand for numbers. So, but the capital letters stand for the numbers that you would normally know in the equation, and the lowercase x, and if you would see a lowercase y, those stand for the variables, or the ones that's going to come up in the equations as x or y. ab times x squared plus bx. We want to factor this out. And the whole thing about polynomials. Okay, poly is a prefix that means many. And nomials means sets of numbers, or groups of numbers. And so what constitutes a set of numbers or a group of numbers in these things? Well, all you have to do is look for the addition and subtraction signs. So I'm going to put addition or subtraction. And those signs are what separates the group. We've been doing two sets of numbers in all of these. So see, we look for the addition or subtraction signs, and there's one addition sign. So that separates this group of numbers from this group of numbers. So that means there's two groups of numbers in this equation. Does that make sense? Okay, so now let's start with the first group of numbers, which is ab times x squared. And we want to factor this out so we can have a common factor number with the other group, the bx, the b times x. So if we have ab x squared, we can have an ax times a bx, because there's x times x, so that will give us the x squared, and there's 1a times 1b, so that gives us the ab. So ax times bx, we could also have ax squared times b, or we could have a times bx squared. And then for the other group of numbers, the bx, we can have b times x, or we can have 1 times bx. So I think you see how that's going, how this works. I think you can see we've done enough problems that you can see this. So what is the highest amount of numbers, or the highest numbers that we can extract out of this equation? We don't have the bx squared in common because this one doesn't have an x squared in it. We don't have an a in common because this one doesn't have an a in it. But we do have a bx in common because there's a bx in this group and there's a bx in this group. So we're going to take that bx out and put it outside of the parentheses. And if we look at the first group, it has bx squared. So if we take a bx out of that, that's going to leave an ax. And then you carry the plus sign down. And then we have the bx group. If we take a bx out of bx, that's going to give us 1. Don't forget to put that 1 in there. And so the answer is bx times the parentheses ax plus 1. Okay, let's do the one on the right. We have ax squared plus abx. So we know that these both have a in them, so we can take the a's out. And this one does not have a b in it, so we can't take the b out. But it does have an x squared, and we have an x over here. So we can take a maximum of 1 of the x's out. And so that is taking 1 of the x's out, and that's taking 1 of the x's out. So that leaves us with, bring this leftover x down, and the plus, and then this one has a leftover b, and that's what stays in the parentheses, and outside of the parentheses is ax. So ax times the parentheses of x plus b. Now, in the middle one, we have a squared times x squared plus abx. And I think you can see from looking at it that they both have an a in common. So we can take one of the a's out of this one. So that just leaves us 1a. And we can take the a out of this group. And then we also can take an x out. We can take an x out of this group. And we can take one of the x's out of this group. So that gives us ax outside of the parentheses, leaving us with the leftover a, the leftover x, bring down the plus sign, and the leftover b, because we took this x out. I forgot to cross that out. So ax times the parentheses ax plus b. So let's try these. The first one is ax plus bxy. Well, we can't take an a out because the other group doesn't have an a. We can't take a b out because the first group doesn't have a b. But they both have an x in common. So we're going to take those x's out and put them outside the parentheses, leaving us with a plus by. Here's the one on the right. We have ax squared plus bxy. Well, they don't both have an a. They don't both have a b. But they both have an x. So this one gets rid of the x entirely, and this one gets rid of one of the x's. So we're going to put an x outside the parentheses. And that's it. That's the only thing they have in common. So that leaves us with an a plus by in the parentheses. Now this last one is ax squared plus abxy. Well, they both have an a in common. So we're going to take those a's out, put it outside the parentheses, and they both have one x in common. So this gets rid of the x's, and this gets rid of one of the x's. So that gives us ax outside the parentheses. So this a is going to be gone, this a is going to be gone, and so that's going to leave us with x plus by. And that's it. Now let's do one more set, or two more problems, because I want to get this cubed practice in here for you. So we don't have an a in both of them. We don't have a b in both of them, but we do have an x in both of them. So this gets rid of this one x if we take this outside the parentheses. But this is x cubed. And remember, x cubed, whatever number this is up here, that's how many times you take the x. So we're going to write the x 3 times and multiply them together. So if we're taking one of the x's out, then that's going to leave us with 2 x's. So we're going to turn this x cubed into x squared. So we have an x outside the parentheses, and then bring down the a, and then we have x squared left, plus b, and we got rid of that x, and just y. So x times the parentheses ax squared plus by. And this one, we don't have any a's in common. We do have b's in common. So we're going to take the b's out. We have one x in common, so this will get rid of this x, and this will just get rid of the second x, the squared part of it. So that's x, bx. And we also have y's in common. So we're going to get rid of this y, and we're going to only get rid of one of these, so that's going to turn it into a y squared. So the outside is bxy, and the inside is going to be ax plus y squared. Ooh, oh no, negatives, negative numbers. I can't let you go without tacking this on because negative numbers tend to confuse a lot of people. So if we have, let's do this one up here first. If we have negative ax minus bx, well, we can take the x's out and put them out here, and then we'll end up with a negative a minus negative b, right? But we could also take the negative x out. So if we take a negative x out, then that's going to get rid of this negative for the negative a, and it's going to get rid of the subtraction sign for the b. And so if we get rid of the subtraction, that turns it into a plus sign. So that would be a negative x on the outside and a positive a plus b on the inside. Now, if that's confusing, it's okay. You just get some practice and you can get used to it. Let's try this one right underneath it. We have a negative 9x minus 3x squared. Well, they both have one x in it in common, so we can get rid of this x, get it outside the parentheses, and this gets rid of one of these x's, leaving 1. But then we have a 9 and a 3. And so if you factor 9, 1 times 9, 3 times 3, and a 3 is 1 times 3, they both have 3 in common, right? So we can take a 3 out of here, and that'll get rid of this 3, and that'll turn the 9 into a 3. But look, they also have negatives in common. There's negative 9, it was negative 9x and minus 3x. So we can also take the negatives out and put them outside of the parentheses. So we'll turn that into a negative 3x. So in the parentheses, we're just going to have 3 plus x. So negative 3x times parentheses 3 plus x. Now let's see if you can do the other ones that I have here on your own. And if you have any questions or any comments or any requests, please don't forget to like and subscribe and leave a comment below the video, and I will definitely get it and get back to you. I love comments and I answer all of them. So your next steps is going to be to study the quadratic formula and FOIL. If you remember FOIL from high school or junior high school, that's good. But if you don't worry, I will talk you through it. So be on the lookout for when I release part 2.